Alright, I'm just going to try this and see what happens. So, hello. This is a response to the video by Veritasium on the bullet in the block. Originally, I had planned to have a little bit of demonstration to go along with this, but it didn't quite work. So, I'm just going to go ahead and give my explanation and leave it at that. Alright, so initially when I saw the video, I fell into the same trap as Destin and Henry, thinking about energy and energy conservation. And when I saw the answer, I really felt stupid because it's a collision problem. So there's two types of collisions, right? There's an elastic collision, which is where two things come together and bounce off of each other. And there's an inelastic collision where the two come together and stick and then move off together. This obviously is an inelastic collision. The bullet embeds into the block. So kinetic energy is not conserved. So we don't want to think about it in terms of energy. We want to actually think about it in terms of momentum. So momentum is conserved in any collision. So in this case, the bullet's going to have essentially the same momentum when it hits the block, whether it hits it in the middle or whether it hits it to the side. It's going to have the same linear momentum. All right, we've got linear momentum and angular momentum, two different things. But the linear momentum is going to be basically the same in both experiments. So what that means is then the linear momentum is conserved, so the linear momentum of the bullet versus the linear momentum of the bullet block combination should be equal. So what that boils down to then is the initial velocity after the collision is going to be the same for the bullet block combination. So if they have the same velocity after the bullet embeds itself in the block, then they're going to have the same kinetic energy from that velocity, and so they should then reach the same height after the collision. So that's the simple explanation of why they reach the same height. But then there was a whole discussion about, well, now you've got rotational energy. Where did that rotational energy come from? That's a good question, except it's phrased wrong. It's not where did that energy come from. It's actually the fact that less energy was lost in the second collision than was in the first. So in the first collision, the bullet embeds itself near the center of mass. In the second collision, it's off center, and we get this rotation where there's rotational kinetic energy along with that the kinetic energy due to upwards velocity. So my hypothesis is that the first bullet embedded itself much further into the block than the second block. And if that is the case, then there was more friction, more energy was lost from the bullet pushing itself through the block than in the second collision. So I had planned to try and actually prove that. So initially, I'll show you what I've got. My results ended up being inconclusive. Initially, I didn't have a rifle. I had either a shotgun or a BB gun. Shotgun was a little too much. So I tried a BB gun with just some simple cardboard taped together. I set this up on a fence post just as a proof of concept, and then I was going to do a full experiment. So I shot it near the center of mass. You see that BB still embedded there. I shot it a little off center. You see the hole there. The BB didn't penetrate the cardboard enough to stick. It bounced off. So that seemed to support my idea that near the center of mass should go deeper and have more friction than the one further away. So I tried to set up my own version. So just some cardboard and some paper clips. I didn't want something too massive, and shooting a BB gun at point blank range into wood is not a good idea. So I tried this. Unfortunately, the BB went all the way through. The same then was also true when I shot it off center. I don't know if you can see that, but there's kind of a flap there that the BB went through. So I didn't pump the BB gun up as much, tried it again. The off-center one still went through. The one to the center didn't make it through because it actually hit the paperclip there in the middle. So if I had more time, I'd mess around with it, try to get that proof. But that's what I would say, is it's not that the spinning block has more energy, it's that the block where the bullet hit near the center of mass actually lost more energy. And that would be my answer. So I enjoy Veritasium, Smarter Every Day, Minute Physics. I actually use them in class sometimes, so keep up the good work.